Okay, today we're going to look at the statewide school district data and we're going to compare regions 1, 2, and 5. So we're going to have to use the one-way ANOVA test. Before we can do that, we need to separate our regions just to 1, 2, and 5. So the way that we do that is we go to data, select cases, if condition is satisfied, if and I'm going to open up my parentheses, pull region over. We want region 1 or pull region 2 or and pull region 5 over as well. Close the parentheses and then click continue. Then hit OK. Now we have region 1, region 2, and 3 is canceled out, 4 is canceled out, and we also have 5. So now that we have the regions that we need, we're going to go ahead and we're going to do our pre-test to make sure everything is normal to proceed with the one-way ANOVA. So what we're going to do is we're going to go to Analyze, Descriptive Statistics, and then we need to hit on Explore. We're going to pull over enrollment for the dependent list, region for the factor list. We need to hit plots, make sure that we uncheck stem and leaf. We have our histogram and of course our normality plots with test as well, and hit continue. Now that we have this, the first thing that we have to look at is the N value. And since the N values are different for each region, we're going to have to use the SIDEC and not the Tukey when doing the one-way ANOVA. So since these are different, we're going to use the SIDEC. All right, next, they all are higher. Well, this is higher than 30. This is higher than 30. So that meets normality, but this one right here is too small of 23. So this one would fail that first test there. Now what we're going to do is we need to scroll down and look at the Shapiro-Wilks, and we can see that region 1 is less than 0.001, region 2 is less than 0.001, and region 5 is 0.08. So the first two, they're less than 0.05. So these are not normal. And then this one, region 5, is 0.08. So that is greater than the 0.05, which would be a test of normality. Another thing that we can do is look at their histograms, and you can see that histogram for region 1 is skewed. And then region 2 is also skewed. And then region 5 should look a little better. Yeah, region 5 kind of hits more of that bell curve kind of there. So we're going to go ahead and we're going to proceed with the one-way ANOVA, but we need to check the homogeneity of variance first for that other test. So the way that we can do that is we're going to go to Analyze, Descriptive Statistics, and actually what we can do is we can go to Compare Means and Proportions, one-way ANOVA, and we're going to pull over enrollment for the dependent list, region for the factor list, and we're going to go ahead and hit post hoc. Now, since that N value, they were all different, we're going to hit the SIDEC and not the Tukey. We're going to hit continue. And on the options, now we have that homogeneity of variance test there. We're going to hit continue and hit OK. Here's our test of homogeneity of variances here. Based on the mean, we have a significance of less than 0.001. So again, since it's less than 0.05, it is not normal. We don't have our variance there. So homogeneity is not met. But for the sake of this assignment, again, you wanted us to proceed with the ANOVA, so we're going to go ahead and proceed with that. So looking at the ANOVA here, we have between groups and within groups, and we have our degrees of freedom. The between groups, that top one is 2, and the bottom one is 158. So that significance is 0.055. Since that is higher than the 0.05, then we would accept the null hypothesis. We would not reject it. So, I mean, in APA style, I'm going to report this as our F value of 2.957. Our degrees of freedom 1 between groups is 2. Our degrees of freedom, the second value within groups is 158. And our p-value, again, is 0.055. So that's greater than the 0.05. So we would accept that null hypothesis. So, I mean, since we accept the null hypothesis, meaning that there is not a significant difference, we're not really going to have an effect size. We can have this 0.036 estimate here, and that 0.036 would give us halfway in between a small and a medium. So really this would be like a small effect if there was a significant difference. But here's another comparison table here to back up that significance. And when you're comparing region 1 and 2, we have the significance of 0.15, which is greater than 0.05. And then we have the comparison between 1 and 5 here. Here's that significance of 0.126. Again, that's greater than 0.05. And then, of course, we're going to compare 2 and 5, and that's 0.893. So all of those comparisons are greater than 0.05. So again, that's just more data to accept that null hypothesis. Now, for the sake of this assignment, if you needed to find the other way to do the effect size, which was shown in the lesson, you can exit out of this table and you can use the general linear model,